So this is just the same thing from yesterday. You don't have to write it down again if you had it written down. F at x, d at x, a little reminder, q at x, r at x. We know now better. This makes a lot more sense. And we did long division. Oh, and then we talked about numbers. I would encourage you, now that you've done the long division and done some practice with this, go back and think about those examples that we looked at yesterday. We looked at this one, right? 5 divides into 122. How many times? It works out to 24, dot, dot. Oh, dear. Is this going to be the same kind of nonsense as yesterday? And then dot, dot, dot. Anyway, our remainder was 2, right? That's what we got yesterday. And we did long division, and just mentioned that for long division, when you're doing some kind of trinomial, like if it's got an x squared, that's what your divisor is. You have to do long division. So we're going to learn something new today. We're going to learn something called synthetic division. You have to know both long division and synthetic division. Remember, I predicted that you will have a favorite. But synthetic division only works when we're dividing by a linear term, like x plus 2. So x squared plus 2 wouldn't work. If you're dividing by a quadratic term, even if it only has 2 terms, a quadratic polynomial, even if it only has 2 terms, you'd have to put in a placeholder term anyway. But even if it does, synthetic division won't work. It only works for a linear divisor or linear factor or linear term like this, x plus 2, or the next one that says x minus 2 or something like that. Synthetic division will work. Everybody got that? So in some cases you will have choice. The nice thing is we're gonna do some work, maybe a little bit tomorrow, but mostly Thursday, Friday. We're gonna start using this stuff, and a lot of them will be x plus 2 or whatever, right? Like they won't be quadratic terms that we divide by. So you get your choice. You could use your favorite, long division or synthetic division. So that's a good thing. And then in the next unit, we do a lot of this again, and same thing, you would have your choice. Okay, so that's a good plus. All right, so here's how we set it up. It's similar to long division, but different in a couple of really important ways that you need to keep the two different. Don't mix one up with the other. Don't start doing some of what we do here with long division and vice versa. Okay. We tend to use a straight line. I don't know why it's not curved. It's straight, and it goes down an extra line. And we put a line on top, I guess, because it looks like division. I don't know. There's not really a great reason for some of this stuff. Just the way we do it. And then inside this little half box, we just list the coefficients of the function, the dividend, the function that we're dividing into, f at x. So what's the coefficient of x cubed? It's 1. What's the coefficient of the x squared term? It's -5. The coefficient of the x term is -1, and the coefficient of the constant, or the constant, is 12, positive 12. So notice how we had 4 terms up here, and I listed the 4 coefficients, but I didn't list the x values. If you listed the x values, it wouldn't be wrong per se. We again, as a standard, we don't, and I think it's a nice way of keeping the two processes separate. In long division, we have the variables, and in synthetic division, we don't. Synthetic division is all about streamlining the process, making it faster, less writing, getting down to business. So that's another reason probably why we don't write variables. Everybody got that? So step 1 is writing it properly, setting it up. Step 2 is you bring down that first variable. I skipped a space. Notice how I skipped a space and I wrote it down at the bottom. Okay, did that on purpose. Everybody okay with that? You got to remember to do that. Like the hard part about synthetic division is the steps don't have a lot of context. It's pure memory, memorizing the steps. And if you miss one step, the whole thing's going to fall apart. Similar to long division, but long division, after you practice a little bit, it's maybe a little bit more intuitive. Synthetic division is just like memorize. Okay, so you got to bring that 1 down. I take the 1, I multiply it by 2, and I put that number here. Then I subtract. -5 minus 2 is -7. And now I just repeat. I take the -7, multiply it by the 2, I get -14. -1 minus 14 minus -14 is plus 14, so that's 13. Okay? What do I do next? Keep going. Take the 13, multiply by 2, that gives me 26. 12 minus 26 is -14. I'm done. Done, right? We got it. Everybody see that? Okay, let's move on to the next question. No, just kidding. Is that not obvious that we're done? So we are done, but where's the answer? This is why synthetic division, like, you got to really memorize the steps, but that was it. It's a lot shorter than long division, isn't it? But kind of strange. So where's our answer? Okay, so therefore, f at x, we're going to write our statement. We know this part, x plus 2, that part's easy. And so right here are the coefficients of our quotient. So it's 1x squared minus 7x plus 13, and that number that I put a box around is our remainder. It's as easy as that. But you see what I mean by there's not as much context. You really got to memorize. You really got to get these steps and know what they mean. But once you've done this a few hundred times, it's super easy. Yeah. What do you think? What's the answer to Megan's question? It's a really good question, but it's one that really you want to think about and see if you can figure out yourself. How do you know? How did I know that this would be x squared? That's what you're asking, right? Don't wait for one of these people to answer. Think about it. What if you got stuck on a test and you had to answer this question? Oh, shoot, I forgot how to do it. How would I do this? What would I do? What do you think?
Your largest exponent in the answer would be 1 less than you have in mathematics column because your dividend is x plus 2, so 1x.
That exactly right. So I took a degree 3 and I divided by a degree 1. So I'm going to have to get a degree 2. Another way to think about that is if I multiply this through, I've got to get that back. So what would I multiply this by to get a degree 3? So it's going to be 1 less. So if we did it with an x squared, it would be 2 less. Except remember I said synthetic division doesn't work if you've got an x squared. So basically it'll always be 1 less than what you started with. Does that make sense? Okay. Really good to think about why. Again, that helps your understanding of all this process in general, I think. Any other questions before we move on? We're going to do 3 more examples. You don't even have to do 100 of these. You do a handful of these, and you've got it. Okay. Anybody notice anything about this example? Missing the x squared term. Did anybody else pick up on that? Just think to yourself, when you're writing the question down, did you pick up on that? Really important that you do, just like long division. We can't ignore that. We need to take that into consideration. But it's the same as long division. So we're going to go 2. We're going to go 5. We're going to go 0. We're going to go -7. And 10. Who remembers what the first step is? Bring that first coefficient, which is a 2 in this case, down. Very good. And then 2 times negative 2. I think the last one was positive 2, right? So we're multiplying by 2, but this is indeed negative 2, so we multiply by negative 2. Very good. And I get negative 4. Continue if you think you've got this. Go ahead. Okay, you can check your answer against mine. If you've done the synthetic division, and then try to write your final statement. And hopefully you got this. So this one's cubic, because it started as a degree 4, a quartic, so now it's cubic, times a linear will give me back that degree 4. My remainder was 68. Okay, I had every term. Just because I had a ghost term up here doesn't mean I have one down here for sure. In fact, I probably don't. And anybody recognize this? This is the same example we did yesterday. Right there. Same answer, so we're good. So either they both work or they both don't work, I guess. In fact, if you're curious about the synthetic division, if it seems weird, compare those two processes and look for what synthetic division is actually doing. Some of you might have already picked up on that, I don't know. But if you look at what it's actually doing, then you can see like what it is, why it works, that kind of thing. But in general, I wouldn't worry too much. Like, it's interesting. Some people are curious. Some people don't like to be told this works, but I'm not telling you why. So if that's true, we can have that conversation. But knowing exactly how it works, I don't think will help you like remember the steps or anything like that, really. So I don't want to get into a big conversation where I try to explain to you exactly what's happening. Synthetic division is just, it's like, hey, let's get down to business. We need to get this done. Long division takes too long. Let's do it, okay? Because we're going to do a bunch of this in this unit and the next unit. So we want to have the fastest way possible. Any questions? Questions. All right, let's do another one. This one I got to help you with as well because it's a little bit different. There's one extra step. But then the next one I'm going to let you try start to finish all on your own. Anybody pick up on anything that's different about this one as you're writing it down, Jason? Yeah, so it's not x plus 1, it's 2x plus 1. So it turns out that makes a fairly big difference in synthetic division. If you were doing long division, it wouldn't really make a difference. Like you'd have to be dividing by 2x, but you just kind of do that naturally. Whereas in synthetic division, we have to kind of add a step to figure it out. So we're going to start it the same way. 2, 7, no ghost terms, right? No missing terms. 2, 7, 13, 25, and 10. Same step to start with. I bring down the 2. But then I divide it. And every step, that step that we add, we're going to have a whole nother line. And every step, and every time we do it, we divide by the coefficient of x. Okay? So I divide by 2 to get 1. Then I do the same thing. 1 times 1 is 1. 7 minus 1 is 6. Divide by 2. Not always divide by 2, folks, right? Divide by the coefficient of x, but in this case, that's 2. 3 times 1 is 3. 13 minus 3 is 10. Divide by 2. 5 times 1, subtract, divide. 1 times 10 is 10. Subtract, I get 0. Watch very carefully. I do not divide the last one by 2. That's my remainder. I mean, 0 divided by 2 would be 0 anyway. But even if I didn't do that, you don't divide the remainder by 2. Again, if you look back on exactly what this process is doing, that will make sense. But I think for now, just memorize that. Just remember that. The remainder you don't divide by 2. The remainder is the remainder. And in this case, we've got a remainder of 0. Is that weird? That leads back to something we were talking about before. Very good. Think about what Jason's saying here. Yeah, it does. And that's a big deal for something we're going to be hinting at tomorrow, but going into on Thursday. So therefore, 2x plus 1, but the coefficients come from the bottom line. So x cubed plus 3x squared plus 5x plus 10. So the plus 0. You don't have to write that, but I'll put that down for now. But like the coefficients come from the bottom line, but the remainder comes from the top. A little bit weird, I know, but it's just the way that it works. I don't know if you've had quite enough experience with this yet. Maybe it's too early for me to ask, but remember I said you'd have a favorite. How many people love long division way more than synthetic division? Well, maybe a couple of people. How many people think they like synthetic division more? Yeah, see, that's what I thought. That was my prediction. Most people like synthetic division more just because it's less writing. You do it in a little box. It's not like this big, long process. But yeah, everybody's different. Questions before we start? The next one? So I'm going to let you try this one. There we go. It's 3x minus 1. So that's the setup. Bring the 6 down. Divide by 3. And then multiply by negative 1. So watch for that. And some people did that like the first step, but then didn't do that in the next one or whatever, right? So then negative 14 plus 2 is negative 12. Divide by 3 is negative 4. So right here, negative 4 times negative 1 is positive 4. So just be careful of that. I'm going to freeze it and give you another minute to finish. I got a remainder of 7. Would it be possible, like all of those numbers were divisible by 3? What if that didn't happen? Would that be wrong? Yeah, it just means you'd have fraction in your answer, which is absolutely possible. Polynomials with fractions are a thing. But just like usual in math class, we're so nice and we avoid them. Just because we want you to learn synthetic division, we don't want you fussing around with fractions. So we don't see them very often. In fact, I bet you on that homework there, I don't think there's one answer that has even one fraction coefficient. So, but that doesn't mean it's not possible. It doesn't mean I'm going to throw that at you on a quiz or a test or something like that either, but just keep in mind that it's possible. It's not like immediately you must have done something wrong if you get a fraction somewhere. But or I always like to say this, if you tried to make up your own question and expected it to work out nicely, it probably won't. Okay, especially these kinds, there's a little bit of work to make up questions where it works out properly. But anyway, any questions about any of this? So that's synthetic division. So now we know both. You need to know how to do both, long division and synthetic division. We need long division because this doesn't work for those other examples when you're dividing by quadratic or bigger degree polynomial. Okay, it doesn't work for those, and it's just a process that we learn. So on your test, it'll be like, do this one with long division, do this one with synthetic division, do these ones with the method of your choice, right? There will be like some variety. So you need to know both, but that's it. And then tomorrow we start looking at some applications of what can we do with this? How does it help us? Tying it back to what we were doing before, the nature of polynomial functions, what their graph is like, what they look like, how can we get more information out of them, that kind of thing.